This is the second video of two about scaling. The first video presented the concept and explained a simple way of scaling pictures down, making them smaller, and then scaling them up, making them bigger. In this video, we're going to take a look at the actual Python code that will do both scaling down and scaling up of an image. So let's take a look at scaling a picture down by a factor of 2. And so that's what this function here on screen is going to do for us. I've decided to name the function descriptively by saying that it's scaled down by 2, by a factor of 2. This function as written is going to prompt the user for a picture that they want to scale. And then once we have that picture, we need to calculate the width of our new picture. And if we're scaling this down by a factor of 2, the new picture is going to be half the width, half the height of the original picture. So we're getting the width of the source picture, the original, dividing by 2, doing integer division so we get an integer response, and doing the same with the height. Once we've got those calculated, we can then plug them into our makeEmptyPicture function that will give us back an empty picture based on those new numbers for the dimensions. Just as an aside, I could have, instead of calculating these numbers and putting them into a variable, plug those formulas in right here, but that made for a very long line, and so I thought I would split them apart for purposes of a demonstration today. That sets up the picture. We've got the picture we're copying from, and we have the empty picture we're going to scale it into. And again, we're making a smaller version by a factor of 2. So the actual code to do the scaling starts with the source x equals 0 line and ends here where we increment it. And then at the end, we're going to return the new image that we've created so that we can do something with it in another program. But let's take a look at the code here. Remember from the first video that if we're scaling by a factor of 2 down, we're going to take every other pixel and copy it over and skip every other pixel. So 1 out of 2 pixels horizontally and 1 out of 2 pixels vertically are going to be copied to the new image, and the rest are going to be ignored. So let's set up a set of nested for loops. We got for new x. This will be an index that we use for the new image, as opposed to the source x and source y are going to be the coordinates we use for the original image, or the source. And we need different variables because they're coming from one place and going to a different place numerically, because we're changing the size of the picture. So we initialize source x to 0 to start in the upper left corner. We do the same for the source y. And then we have the for statement generate a new x and a new y for us for the new picture. In both cases, we're using the range starting at 0, and then in the case of x, going to the width of the new picture, and for the y, going to the height of the new picture. Remembering that those are half the dimension because of our calculations up here. Once we have the structure set up to generate the source x, source y values and the new x, new y values, then it's just a matter of getting a pixel from the original, getting its color, getting a pixel from the new, and setting its color. And so we're doing that in these two nested lines here. Just like in math, we work from the inside out. So first we're getting a pixel from our source picture at source x, source y, and that pixel then is being fed into get color to get the color of that pixel we just retrieved and replacing that into a variable called color. Similarly, we're going to do a set color of the pixel that we retrieve from the new picture at the new x, new y coordinates. And we're going to set that new pixel to the color that we just retrieved from the original source pixel. So we got the old pixel, got its color, we got the new pixel, and set its color. Once we've done that, we're ready to go to the next pixel. But because we are responsible for controlling the values of source y and source x, we need to increment our source y value now. Because we're getting ready to go to the next y, we need to skip over a pixel, so we're going to add 2 to our y coordinate. And that goes around and basically does all of the first column of pixels, skipping every other one and copying half of the pixels into our new image. Once we've done the first column, done the full Y range, then it's going to come back to the next X value for the new X and go through the same process. And so now we're basically think about being in the second column of pixels in the new picture. It would actually be the third one in the original because we skipped over one. And you'll notice that at the end of the 4Y, we also increment our X by a value of 2. Again, to skip over a column because we're taking every other column of pixels and every other row of pixels. So plus 2 on the Y, plus 2 on the X. But notice they're adding to the Y is inside of the Y loop, adding to the X is outside of the Y loop, but inside of the X loop. Once it runs through all of that, we have the completed image, and so we return the new picture. So let's do a quick run of this and confirm that our code works and see what we get. So scale down by 2. It's prompting me for an image. I'm going to choose the same one that we had on screen before, the Big Ben image. And it's just come back and said picture, file name none, height 234, width 100. Why is it doing that? Well, the last thing our function is doing is returning the picture. We didn't do anything to receive the picture in that we didn't assign it to a variable or we didn't feed it into another command, so it's basically just kind of dumping it on the screen for us. So instead of saying scale down by 2 by itself, let's wrap this inside of an explore statement. And then the output from scale down by 2 will become the input to explore. So again, I'll choose Big Ben. It opened off screen, and there is our shrunken version. Let me bring back the original. So there's the original, and here's the new. And I think you can visually see that it's twice as tall and twice as wide. So that's the scaling down version. We take every other pixel horizontally and every other pixel vertically to produce the smaller image that's half the size. And again, we're doing every other one because we're scaling by a factor of 2. If we were scaling by a factor of 3, we take every third pixel in both dimensions, etc. So that's scaling down. Let's take a look at what it would be to scale up a picture. For instance, can we take this small version and scale it back up to the original size? I've got that code here. You'll notice it's very similar in nature, but a little different. Start out the same. We let the user choose a picture to scale. And in this case, since we're trying to make the picture bigger by a factor of 2, we're going to take the original width and multiply it by 2. You may remember when we're scaling down, we divided by a factor of 2. But here we're multiplying the width and height by 2 to get the new dimensions. We make our empty picture based on those. We're still going to do the same thing with our source X, new X, source Y, new Y, in terms of initializing the source values to 0 and creating the for loops with the range 0 to width and height of the new picture. Inside, we're substantially doing the same thing in that we're getting a pixel and getting its color, getting a pixel from the new picture and setting its color to the color of the source pixel. So I'm going to resize the window here so we can see all of the line. One thing different is that we've surrounded our source X and source Y variables by the int function. The int, as you're familiar with, takes the value and turns it into an integer by simply truncating or ignoring anything after the decimal point. The reason we're doing that is that getPixel is expecting integers for the X and Y coordinates. If we give it a real number, it'll generate an error and the code will not run. But then the question is, well, why are we getting real numbers here, or floats, instead of integers? And that answer is down here, where we're incrementing our source Y and source X coordinate values. I'm going to scroll back to the first scale function, and you'll note that we were adding 2. And the reason here is that we were scaling down, we're making it smaller, so we were adding 2 to skip over pixels. But here when we're scaling up, we're not wanting to skip pixels, we're actually wanting to duplicate pixels. So for every pixel that we have horizontally, we want to put it in twice. And we want to do the same thing vertically, putting it in twice. So the same pixel will end up in 4 places in this new image because we're scaling it up by a factor of 2. If we were scaling it up by a factor of 3, we'd put each pixel in 3 times horizontally, 3 times vertically, so we'd end up with a block of 9 pixels that are all the same color. The way we're accomplishing that duplication is that we're adding 0.5 because we're doing it by a factor of 2. And so the first time through the loop, source y has a value of 0. And it retrieves the pixel based on that. And then after we've processed the first pixel, we add 0.5 to it. So now source y has a value of 0.5. When it comes back around the loop and does the retrieval of the pixel from the source picture, it converts the 0.5 to 0 via the int function. Remember, it truncates, it doesn't round. So it's retrieving the 0 entry a second time and placing that into the new picture. When we finish that, we add 0.5 to what was previously 0.5, and now we have 1. And so when we come back around the loop, the y value has a value of 1, and it retrieves the next pixel underneath the first one. And it adds 1/2 to that, so now it's 1.5, which translates into 1 again and duplicates the second pixel the second time. And it just repeatedly does that, and we have the same thing happening on the x dimension. As we go across, we add 1/2 because we're scaling by a factor of 2, and that ends up duplicating each pixel horizontally. Once that's all done, we do the same thing of returning the new picture, and then that can go back to whoever's calling this function, and they can do something else with that picture. So hopefully that makes some sense. It's a little bit to wrap your mind around, but for most people, once they study it a little bit and grasp what's going on, things start to make sense. Again, just remember that if you're scaling up by a factor of 2, you're going to double pixels. If you're scaling down by a factor of 2, you're going to skip half the pixels. If it's a factor of 3, it's going to triple pixels or skip 2/3 of the pixels. So the factor of your scaling determines how much you're skipping over or how much you're duplicating, depending on whether you're scaling down or scaling up. We'll see you in class.